class, we finish up the blood. In lab, we covered blood typing, and then in, I think yesterday I wrapped up the blood clotting stuff, right? I'm remembering correctly. We did blood clotting last time?
Yeah.
Okay. So we'll be moving on to the heart. All of you have been introduced to the heart through the lab material. So I'm going to leave a little bit out or leave it to lab material for you to get. So let me just sort of walk through the book and cover stuff. The physiology that has to do with the heart is kind of the tough part of this chapter. So I want to sort of get through the anatomy stuff as much as possible quickly so we can move on into the, yeah, that's good. Move on into the physiology stuff. So I showed you in lab the location of the heart. There's a model that had sort of the see-through walls of the lungs, showing you the heart in the middle of all of that, the mediastinum. I think both Monday and Wednesday I kind of glossed over this, but I want to be sure I say it in a little bit more detail. The heart has sort of two sides. We talk about the base and the apex of the heart. The word base usually means the bottom of something, and then the apex usually means the top or the point of a mountain kind of thing. In terms of the heart, they actually don't mean that. The base of the heart is sort of the top of the heart, and the apex is the bottom. The base of the heart is where all of the major vessels are attached. So it's sort of here where the atria are. And in fact, that's where the heart's attached. And then the apex is the sort of pointy end next to where I have the mouse here, which is a little bit off to the left side. I introduced the EKG, and we'll talk about that some more. Hopefully I'll get to that today. The way that we record the EKG and the information we pay attention to is really based on the axis going through the heart from the base to the apex, sort of that line going parallel to the right arm, left leg electrode pair. So it goes there. And when the heart contracts, when the ventricles contract, they start contracting at the apex and squeeze up towards the base. The base is where the aortic and pulmonary valves are located. So when the ventricles contract, they're basically pushing the blood up towards those valves. So we see that there. I didn't mention in lab, I used this picture to talk about the chambers, valves, and vessels. I didn't point out the other part of this figure, which is a very simplistic version of what circulation is. We usually talk about circulation falling into the pulmonary circulation and the systemic circulation. So pulmonary is the heart to the lungs and back to the heart, which is represented by what's in the middle of this figure here. And then systemic is from the heart out to the body and back to the heart, which is represented by the two loops, one going towards the head and neck and one going down towards the lower body in this picture. In actuality, it's a bit more complex than that. There are arteries going out to all the tissues of your body. And if we were to draw a picture of the systemic circulation, it would look like the shape of your body because it's going everywhere. Like the pulmonary circulation is basically the shape of your lungs and your heart together. Okay. The two loops of circulation are basically a figure eight. The right side of the heart receives systemic blood that's been deoxygenated and pumps it to the lungs. And then from the lungs, it goes back to the left side of the heart, which then pumps it out back to the body. Okay, so it's right side to the lungs, lungs back to the left side to the body, back to the right side, and just sort of loops around again, and you can kind of a picture of it as a figure 8 series of loops. Now in the picture there, it doesn't look like a figure 8 exactly, because the systemic circulation is going 2 directions, up into the head and neck and down into the body. And likewise, you can think of the pulmonary circulation as going 2 directions, towards the left lung and towards the right lung. So the figure 8 idea doesn't quite fit. But if I were to just draw a picture depicting these, hopefully it works. It's red. Okay, well, it's red, which is blood color, so yeah. So you think of it as from the heart, you have the pulmonary circulation and the systemic circulation. And it would follow through. These are not at all anatomically correct. Okay, the heart's in between the lungs, not below the lungs. But the idea is that blood goes through the pulmonary circulation and then through the systemic circulation, and just keeps going around and around like that. So it's sort of a figure 8 suggestion. Again, not anatomically figure 8, but those 2 loops kind of interact together like a figure 8, as I suggested there. Now, something I didn't address in lab is the tissue structure of the heart. The heart, as I've already said, is found in what's called the mediastinum, the space between the 2 lungs, along with some other organs like the trachea and the esophagus, and the aorta, et cetera, et cetera. The heart has a serous membrane covering its outside and lining the inside of the mediastinum, which is called the pericardium. It's a simple squamous epithelium and its associated areolar connective tissue that's on the outside surface of the heart and the inside surface of that cavity. The 2 layers of that membrane are opposed to each other, as we see here. The apical surface of the simple squamous epithelium lining the inside of the cavity is this side of the picture, and the apical surface of the simple squamous epithelium lining the heart is this side of the picture. So the 2 apical surfaces are facing each other. There's a little space in between them called the pericardial cavity, which is filled with a fluid, pericardial fluid. And when the heart beats, it is protecting, the pericardium is protecting the surrounding organs by reducing friction of the beating heart against those organs. The pericardium is also anchored in place by a layer of fibrous connective tissue, which would be dense irregular connective tissue, which is referred to as the fibrous pericardium. That's just on the whole outside of everything. The fibrous pericardium and the rest of the pericardium that lines the mediastinal cavity is called the parietal layer of the pericardium. Parietal, when we're talking about layers of tissue like this, is referring to what's lining the body wall, cavity wall. And then the portion that's covering the outside of the heart is the visceral layer of the pericardium. Visceral meaning organ, so it's the layer that's on the organ. And then the 2 layers, the visceral layer and the parietal layer, are separated by a cavity filled with fluid. The visceral layer of the pericardium is also the outermost layer of the heart itself, okay, which is called the epicardium. So the epicardium is just the simple squamous epithelium and its associated connective tissue covering the outside edge of the heart. Okay, it's this layer here. And then most of the heart wall is cardiac muscle tissue called the myocardium, which just means heart muscle. The inset that we're looking at here is specifically showing you part of the left ventricular wall, and the myocardium is thickest in the left ventricle. It's a little bit thinner in the right ventricle, and it's a lot thinner in both atria. The thickness of the myocardium corresponds directly to how much work it has to do, how far it has to pump the blood. The left ventricular wall, what's suggested in this picture, is very thick because it has to build up enough pressure to push blood throughout your entire body and back around to the heart. The right ventricular wall is thinner because it only has to build up enough pressure to push blood to the lungs and back to the heart. And the atria walls are both very thin. Left or right doesn't matter. They're both very thin because they only have to build up enough pressure to push the blood from the atria into the ventricles. And then the innermost layer is called the endocardium, which is a simple squamous epithelium, again, not at all related to the pericardium. It's called the endocardium. But it's a layer of simple squamous epithelium lining the inside of the heart, giving it a smooth inner surface, a continuous inner surface. And the endocardium is continuous with what we're going to meet in the next chapter called the endothelium, which is the simple squamous epithelial wall lining blood vessels. So as the blood's moving through the cardiovascular system, it's moving along a smooth inner surface. When we're in the heart, we call it the endocardium. When we're in a blood vessel, we call it the endothelium. But it's just a continuous, simple squamous epithelial lining to the whole cardiovascular system. So those are the three layers of the heart: the endocardium, the myocardium, and the epicardium. The epicardium is just the visceral layer of the pericardium, and there's also a parietal layer, which includes dense irregular connective tissue, the fibrous pericardium.
Question.
Yes?
In the pericardial cavity, there's nothing in it?
There's fluid. So serous membranes are called serous membranes because they secrete a fluid which generally can be called serum. That's where serous comes from. So the pericardium secretes that to act as a friction-reducing agent, lubrication, for the beating heart against the rest of the surrounding organs. We'll see the same thing in the lungs that do something similar to cut down on friction, as well as something that's important for breathing. And then we'll see the same sort of thing around the digestive organs, and there again, the serum that's secreted is lubricant, so that as the organs move within the cavity, there's no friction as they rub against each other.
Also, the fibrous pericardium, is that like, is the texture like, the dura of the brain?
I suppose you could say, sure. I haven't personally interacted with a fibrous pericardium. I have personally interacted with the dura of the brain. They're both fibrous tissues. I don't know necessarily if the fibrous pericardium is quite as durable as the dura, but it's the same kind of thing. In the midst of answering it that way, I was also going to add something else. It's essentially the same kind of tissue that you'd find in a tendon or a ligament. My only experience interacting with tendons and ligaments is cutting them off for chicken in the kitchen, which is not a very good indication of what that tissue really feels like. But when I have dealt with dura, they're really strong fibrous sort of caps that sit over the brain. I don't know that the fibrous pericardium is quite that dense of a tissue, but it's still a dense irregular connective tissue. So you're in the right neighborhood. And I really just don't have any personal experience of interacting directly with the tissue that is a pericardium. Because as I've done dissections, I've always done nervous system dissections. I've not really actually done cardiovascular system dissection before. So.
All right.
Okay, so that's the structure of the heart. I don't think it's going to come up right now, but eventually, and I showed this picture actually in lab too, we're going to look at what the myocardium looks like, what cardiac muscle cells look like. I don't think it's the next thing. No, it's not. We won't deal too much with the external anatomy of the heart. But as you look at it, you can usually tell the difference between the ventricular and the atrial regions. The tissue just looks kind of different. The ventricles are usually covered in, not covered in, but they have fat deposits sitting on top of them, like we see these sort of regions here that are lighter color. That's adipose tissue, which is a energy-rich storage compartment. All that lipid can be broken down for energy to make ATP that the heart needs to for its muscles to contract. There are major blood vessels that are found in the external wall of the heart called coronary vessels, coronary arteries, and coronary veins. And they're very important, supplying oxygen to especially the ventricular walls. We don't see those on the atrial walls too often because the atrial walls are so thin. They can get nutrients directly from the blood that's passing through them. But the ventricular walls are too thick for oxygen, whatever that's in the blood that's being pumped by the heart to seep in from the lumen of the heart. So there are coronary arteries on the outside that allow, that provide nutrients and oxygen to the ventricular walls. They are branches right off of the aorta. So right about here, there's a branch coming off the aorta that splits into two major coronary arteries. One going to the right side and one going to the left side. The right coronary artery also sort of wraps around to the posterior side of the heart, and the left coronary artery stays mostly on the anterior side. I didn't talk about this when I was talking about the ventricle last time, but the right ventricle is mostly anterior, and the left ventricle is mostly posterior, or more posterior. Which is kind of the opposite of what I just said with the arteries. The right coronary artery, which can supply the right ventricular wall, wraps around posteriorly where it can also supply the left ventricular wall. And the left coronary artery, which supplies the left ventricular wall, also is more anterior, supplying blood to the right ventricular wall. So the two arteries are both positioned in such a way that they can supply blood to both sides of the ventricle.